there are two different types of technology out there that I want to stress and talk about. One of them is more observation. It uses a thermal video camera as well as a black body emitter, and the two of them work together to create an observation system to look at people in a group and try and determine who has an elevated body temperature. Now, these are costly cameras. You need VMS, monitors, more human intervention, and then you have to react to that situation. So why not think about eliminating a majority of that equipment, taking human intervention and moving it away from that area by going with a controlled device. And our SpeedFace Plus reader is a controlled device. It can be used at a door, it can be used at a turnstile or a gate, as well as just being a standalone device on a stand, monitoring body temperature and mass detection. It could be that simple. Or it could be integrated to a full function access control system, which I'll talk about. So here's what it looks like when a person walks up to the reader. It's going to ask them to position their face and move forward. They get within 18 inches. It's going to monitor their body temperature within 0.6 degrees Fahrenheit. It's going to analyze whether they're wearing a mask, and it's going to grant them access based on those parameters. We can take it a step further and add palm vein as a credential, as well as if they were enrolled, add their face credential to allow that to be another criteria. But right now we're using it for a visitor where we do not have them enrolled in the system. They don't need to have their face template analyzed and enrolled in the system for a credential to gain access. We're just using this for body temperature and monitoring of guests. These readers here, there are high-speed visible light facial recognition readers with palm vein. You can get detected within 8 feet, and then within 0.3 seconds, it'll read your face and you can gain access. It's a proven, patented technology that's on a high-performance Linux platform.
That our devices, they're not storing faces by default, and they're not matching faces. These are biometric devices. The face images are converted into templates, which is an unrecognizable encrypted code which cannot be reverse engineered to create a face. It's impossible to create a face.
The device itself, it can be a standalone device. It could be standing on a pedestal, looking for just body temperature and or mass detection, and beeping or saying thank you, or triggering an alarm, contact to light a light. We can have that device not only be a reader, but a panel, a true access control panel to control a whole door. We can also use it just as a WGAN reader on an existing system, where now all we're doing is installing the reader, tapping the power, and we're communicating with all the existing lock hardware. And we can communicate to our software through TCP/IP, whether it's through LAN or whether it's through Wi-Fi. We can store 50,000 face templates at the device, as well as 5,000 palm vein credentials at the device. We can again detect body temperature within 0.6 degrees Fahrenheit within 18 inches at the device, as well as do our mask detection. We can actually recognize you with or without the mask to allow you to be granted action based on your credential. Or you don't need to be enrolled as a 50,000 template to be granted access. You can be a visitor. We can have 100,000 visitors come through and just have their body temperature and their mass detection detected, alerted. We stop, we monitor, we alert, and we let them through. We can use the high-speed visible light camera, which is underneath the thermal pile sensor here. It uses both visible and infrared light to do the analyzation of your face. So we're not just sending video, because we don't send video. This is not a camera. This is nothing more than using these cameras to identify and to create those ones and zeros and to come up with that template. We also can operate in total darkness. We can operate in high visible light of up to 50 lux. This is what our ZK Biosecurity Software looks like. And it is an application that you install on a small server. You put it on a LAN. You then have the readers targeted towards the server, And it's a closed network. It's not cloud hosted. There's no cloud feeds. It's licensed per reader, and it does all the monitoring and reporting that you need, as well as central programming. I can actually go in through the software, and I can address multiple readers, and I can set their threshold for body temperature alert, whether or not I want mask detection to deny access, whether I want unregistered users to gain access based on meeting those credentials. So not only can we monitor abnormal temperatures with faces if we choose, no mask alerts, normal activities, we can chisel down and do some reporting, and we can get some raw temperature reports on a user that was unregistered, at what time and date, what area, what reader, and were they normal. So if we get some red flags, we know where the person was and what time they came in. We do have the ability to opt in, if you choose, to get a snapshot and bring it over with that face if there was an elevated temperature and or mask alert. We do have email alerts. So if I go into a reader and I get a transaction, and then my software in the background, it would actually send me an email. It would show me the alert in red, no mask. It would tell my body temperature, who I am, if I was enrolled.
So we're finding in many cases, customers with existing card access systems, they're actually connecting the SpeedFace tablet right next to the card reader. So now they authenticate with their card. They then have their body temperature scanned by our SpeedFace reader. And if they fail that inspection, that badge number is not sent to the access control panel the customer already has.